We have an example problem here. A uniform linear charge density of lambda is distributed along the entire x-axis. Consider a spherical surface with radius r centered on the origin. What is the electric flux through this surface? So our answer is going to be symbolic. So very long, infinitely long, linear charge density lambda. And we have a spherical surface centered on the origin. So the y-axis would be right there. Okay, this spherical surface is a closed surface. This is considered a Gaussian surface. And we want to find the electric flux through this surface. Gauss's law, we're looking at electric flux. It's the closed integral of E dot dA, but it is also equal to the charge located inside within this surface divided by epsilon naught. So if we can find the charge located in this surface, then we can determine that flux. Well, this sphere has this portion of the electric field. Not the electric field, sorry, the linear charge density. So Qn is just that length of this entire uniform charge density. Well, the length of this is 2r, right? We have r here, we have r here. So we know the length of this segment. We know this is a linear charge density. Linear charge density is a ratio of charge per length. That can represent a total charge over a total length, or it can totally represent the charge in that section, so within this sphere, divided by the length of the charge within the sphere. So Qn would be lambda times the length of the segment that is located within that sphere. So it'd be lambda times 2r. So our electric flux will be lambda times 2r over epsilon naught. We could, of course, write this as 2 lambda r over epsilon naught. This would be the electric flux through this spherical surface. So we would just need to know how much, the value of the linear charge density and the radius of the sphere. Now, just on a side note, in terms of the integral, this would not be an easy problem to solve. And that's because, the electric field is I'm making the assumption that this linear charge is positive by drawing these lines, electric field lines, pointing away. So they would not have the same value as they passed through the surface of the sphere. So solving this problem using the integral would be not easy to do. But that's okay. Gauss's law is beautiful in that how we just solved it, knowing how much charge is located within that surface, is enough to solve for this electric flux.